Homework 16, Exponential and Logarithmic Equations, Video 1. In the previous videos, we've talked about exponential functions, we learned what logarithms are, we learned some properties of logarithms, we learned some tricks for evaluating logarithms, we learned some ways to condense expressions, to expand expressions. In the previous, I just realized there was something I neglected to mention in the last video as to why we condense as opposed to expand. I did say in one of the expanding videos that that was advantageous in a calculus context, but the advantage to condensing is it makes solving equations easier. Not the one that's on the board, but down the road in this series of videos. As the name implies, there's two types of equations in this section, exponential and logarithmic, but within each of those there are two types. So two types of exponential and two types of logarithmic. But for each type I want to show at least 2 videos, so I'm expecting 8 videos in this series. So let's start with the exponential equations. And I'm going to categorize these as same base equations. This will be part 1. What do I mean by same base? Well, let's take a look at this example. Solve 5 to the 3x minus 1 equals 625. These sides of the equation do not currently have the same base. The base on the left is 5. The base on the right is 625. And if you're thinking, why is that a base? It doesn't have a power. Everything has a power, even if it's just 1. So right now, these are not the same base, but maybe I can fix that. So I'm going to give you some steps for how to solve exponential equations when you can use the same base. So step number 1, if possible, rewrite one or both sides of the equation. One or both sides of the equation to reveal matching bases. So in other words, both sides need to say the same number raised to different powers. Currently, this says 5 to the power on the left and 625 to the first power on the right. So these bases are not currently the same. This one's 5, this one's 625. But maybe we can take the 625 and break off some 5s, and maybe it's a power of 5. If I divide 625 by 5, I get 125. If I divide 125 by 5, I get 25. Aha! If I divide 25 by 5, I get 5. 625 is made up of 4 5s. 625 is 5 to the 4th power. So, I can rewrite the right side of this problem as 5 to the 4th power. I did not need to rewrite the left side, it was already a power of 5. So I just revealed matching bases. Both sides have the same base. If you can get the same base on both sides, your second step, in fact the rest of the steps are pretty easy. Cancel the bases. That's not what really happens. What really happens is you're equating the exponents. Equate the exponents. To equate things means to set them equal to each other. Visually, what seems to happen is that these cancel. That's not technically what happens. It has to do with the fact that exponential functions are one-to-one and invertible, but let's just say you cancel the bases and equate the exponents. So in other words, the only way 2 powers of 5 can be equal is if their powers are equal. Well, the rest is easy. Finish solving. Now be careful. This can be straightforward, it can be trickier. This one's straightforward. This is a linear equation. I just have to strip down the x by doing all the things I would normally do, like adding 1 to both sides to get rid of the minus 1. Or dividing both sides by 3 to get rid of the times 3. Oh no, we got a fraction. Big deal. You're in college, deal with it. So solving can be easy depending on the caliber of equation. This could be quadratic, so we would have to solve it that way. It could even be an absolute value equation or a polynomial equation, and we have to whip out synthetic division, Lord help us. But I don't think these are going to get beyond quadratic, and honestly, I think most of these will turn into linear equations. So the solving should just be a matter of moving through it and finishing it. We're going to do another example of same base problems because the first step said rewrite one or both sides, and in this case we only had to rewrite one side. I want to show you an example where it's not only, it's absolutely necessary to rewrite both sides.